All right, so this section is on similar polygons. And two things need to happen in order to be a similar polygon. The first thing is that angles need to be congruent. The second thing is that the sides need to be proportional. We're used to talking about congruent polygons. So we're going to move from being congruent, where everything, all the sides and all the angles are the same, to similar polygons, where all the angles are the same, but the sides are proportional. So in our first example, we have pentagon JKLMN and STUVW are similar. And let's grab. So we're going to list all the pairs of congruent angles. So we're going to make a column for all the angles that are congruent. And then we're going to write an extended proportion for the ratios of all the corresponding sides. So then we're going to make a column for all of our corresponding sides. So when we look at our angles, we see that angle J, and we can look at our statement to also get this information, is congruent to angle S. Angle K is congruent to angle T. L is congruent to angle U. And M is congruent to angle V. And our fifth angle, N, is congruent to W. So listing all the angles congruent is pretty easy. You just have to remember all five. And then the sides, you can either look at the figure or you can read the congruent statements to figure out which sides are congruent. JK is going to be congruent to ST. So JK is congruent to ST. Sorry, JK is proportional to ST, and that should equal KL being proportional to TU. And then if we look at the diagram, KL and TU are the corresponding sides. We follow that same pattern out, and we get LM and UV, MN and VW, NJ and WS. And those ratios of the corresponding sides are all going to be congruent. All right, so let's look at an example of how we would apply this. We have two polygons here, XYZW and QRSP. If they are similar, then the ratio of their sides, XY over QR, is going to equal the ratio of YZ over RS, which is here, which is going to equal to the ratio of ZW to SP, which should equal the ratio of PQ to W, or WX to PQ. So we're going to fill the numbers in for this similarity statement. So that's 6 over 4. That is 9 over 5. That's 12 over 8. And that is 15 over 10. Then we're going to simplify each of those fractions. So we get 3 halves, 9 fifths, 3 halves, and 3 halves. Since this is 9 fifths and not 3 halves, the two figures are not similar. All right, we're going to talk about scale factor now. And scale factor is the reduced ratio of the side lengths. So for here, it would be 3 halves. So for this figure in example 3, it's going to be 15 over 12. And we're going to go ahead and reduce that. So we divide both top and bottom by 3 to get 5/4. This would still be 5/4 if I picked the hypotenuse of these triangles as my corresponding sides. So if I did 25 over 20, I would still, when I reduced it, get 5/4. All right, here we're going to find the missing variable for these similar polygons. So the first thing we're going to do is we're going to go actually, let me modify this. So in this case, 10 over z is going to be equal to 15 over 6. And this is a z. And when I cross multiply using the cross products property, we get 6 times 10 equals 15 times z. I divide both sides by 15, and I get z is equal to 4. So I'm going to apply that same property to these similar rectangles. So I'm going to set up my proportion, x over 2.4 equals 9 over 5.1. And when I do that, I just erased. When we do that, we get 5.1x equals 9 times 2.4. So we're going to multiply the 9 times 2.4 to get 21.6. And then we're going to divide both sides by 5.1. When we do that, we get x equals 4.2. And that's the end of our lesson today. Thank you.